Okay, let's talk about work. We've just learned that mechanical energy is conserved. That means that the mechanical energy is the same at the beginning of a problem and at the end of a problem, and also anywhere in between. Alright, so mechanical energy is the same number throughout the whole problem. Beginning and end, they're equal numbers. We can see that on the scale right here. When you add up the kinetic energy and the potential energy, that's why you get mechanical energy. If you do that in the beginning, you do it at the end, the kinetic energy and potential energy might be different, but the total is the same. They balance out. However, this is only true if there are no outside forces besides gravity. So things like friction, or motors, or somebody pushing or pulling. If there are outside forces acting on the object besides gravity, then mechanical energy is not necessarily conserved. For instance, if there's friction, we know that objects will get slower and slower, losing kinetic energy. So maybe this skateboard is going along, whee! But when there's friction, he slows down. So he doesn't have the same amount of energy as he did before. And he's slowing down even though he's going on a flat surface. He's not going uphill or anything. It's just the friction is taking away some energy. When energy is taken away from or added to an object, that means, taken away, added to, that means there is work. And that's what we're talking about today. Something called work. So it's a very specific thing in physics. It's not just, a job or something. In physics, work has to do with energy being taken away from or added to an object. In other words, if the mechanical energy at the start is different from the mechanical energy later, then some force did work. Again, if the mechanical energy at the start, like this one before, is different from the mechanical energy later, after, see how they're different? The balance is all out of whack, they're not balanced anymore, then some force did work. So the mechanical energy before and after, if they're not the same, then something did work. We call the work positive if it adds energy. So here we have our initial mechanical energy, the mechanical energy in the beginning. Here we have the final. If we add some energy, if we add some work, in order to get a bigger final mechanical energy, then we call that positive. And the opposite is true too. If it's energy being taken away, we call it negative. So here we have a bigger initial mechanical energy than a smaller final mechanical energy. So if we're subtracting energy, if we're taking energy away, really that's energy being taken away. That is the work. We call the work negative. For instance, friction does negative work because it takes energy away from skateboarders. So this guy's going really fast, whee! But then he slows down. Alright, he's slow because friction did negative work. Friction did negative work. He was fast, he slowed down, he had less mechanical energy at the end because there was friction that did negative work. On the other hand, engines do positive work because they add energy to cars. So you have the car going kind of slow, and then the car is racing on by, and that's because the motor added energy. So it did positive work. So work is how much the mechanical energy has changed. So to calculate work, we need to calculate the change in mechanical energy. We can do that by taking the final mechanical energy and subtracting the initial mechanical energy. Alright, to visualize that, if we have a mechanical energy before and after like this, we're trying to find what's this extra amount that was added. Or if we start off with more mechanical energy than we ended up with, we want to find out how much energy was taken away. That's the work. Work is how much energy got taken away or added to. So here are the steps for calculating work. First, you're going to find the mechanical energy at the beginning of the problem. Remember that mechanical energy is the potential energy plus the kinetic energy. Then you're going to find the mechanical energy at the end of the problem. So we did the beginning, now we find the mechanical energy at the end of the problem. Third, we take that energy from the end of the problem and subtract the energy from the beginning. So we got the ending mechanical energy, subtract the beginning mechanical energy, and that's the work. All right. As physicists, we like to write this change in mechanical energy like delta. It's always the final minus the initial. Now, if you get a positive number, that means work was added. If your work was a negative number, that means work took away energy. If the number is 0, then there's no work, and that means energy is conserved. And the unit for work is joules, because work is just a change in energy, and the unit for energy is joules. Sometimes there's not enough information to find the exact value of the mechanical energy. Remember that mechanical energy is potential energy plus kinetic energy. Sometimes the problem will just give you how much potential energy has changed. So like if you're lifting a box, you're changing the potential energy, but maybe you don't do anything to the kinetic energy if it stays at rest at the beginning and the end. Because there's no information here about the speed or the kinetic energy, we just know about the change in potential energy. You could also have a problem where the kinetic energy changes, but the potential energy stays the same. In cases like these, you just figure out what the change in the potential energy is, or just what the change in kinetic energy is. So whatever's changing, whatever amount of energy is changing, just find that, and that change is the work. Alright, so the work is always the change in energy. So remember, work is the amount of energy that is added to or taken away from an object's mechanical energy. That's what work is. All right, now it's time to get to work.